Okay, so taking a look at example 2, we're going to look at the limit as x tends towards 1 for the reciprocal graph 1 over x take 1. So we've drawn the graph for you, including the asymptote, and look, oh, the asymptote is at 1. So if you approach 1 from the negative side, in other words, the 0 point somethings, you're heading towards minus infinity. If you come at it from the other direction, the 1 point somethings, you're heading towards positive infinity. So the limit as x tends towards 1 does not exist. And you can see if we put this into our calculator using the limit button, and that's a really useful button for calculator papers, it says it's undefined. So if you type in 1 negative, it tells you it's negative infinity. 1 positive, it tells you it's infinity. So it's telling you which way the graph is heading, so it's great for sketching, but it also tells you the graph is undefined at that point. Okay, so now let's take a look at the graph as of x take 1 all squared take 3, which is in turning point form, as x approaches 3. Okay, so there's the graph drawn for you, and it looks pretty good. So as we come at 3 from the negative side, we're getting towards 1. As we come to 3 from the positive side, we're getting towards 1, and therefore the limit is 1. So that's nice and simple. Obviously, if you can see the graph, it's even better than if you have to draw it yourself. So, in general, if f of x is continuous at x equals a, then the limit will exist. So in other words, if you don't have to pick your pen up while drawing it, the limit exists.